Assalamualaikum warahmatullahi wabarakatuh, and very good day to all of you. So for part number 6, chapter number 3, we will discuss about the compressor cascade correlation in terms of Mach number effect. Okay, before we start our discussion about the Howell investigation in terms of Mach number effect, let discuss what I call the basic knowledge about Mach number in compressor cascade in terms of Mach number equation, and also Mach number terminology that will be used in our discussion. So first, we discuss about the Mach number equation, where Mach number represented by m equal to c divided by a, and also equal to c divided by square root gamma RT, where c equal to fluid velocity, a is speed of sound, which is equal to 343.59 meter per second at 20 degrees Celsius for air. Gamma is specific heat ratio, R is for gas constant, and T is temperature. Okay, so the figure shows this what I call the part of the experiment setup for the cascade blade compressor cascade blade investigation that conducted by Howell, where we can see the condition involved, the parameter involved at the inlet of the cascade blade, where we can see here the parameter involved is C1, inlet flow velocity, and also incident angle I. At the outlet, the condition in terms of parameter involved is C2, outlet flow velocity, and also d delta for deviation angle. So in Howell investigation in terms of Mach number, Howell need to change the value of inlet Mach number. So inlet Mach number can be changed if we change the value of inlet fluid velocity C1, because if you refer to the equation, m1 is a function of C1. So inlet Mach number depend on the value of inlet fluid velocity. Okay, so now we look at few terminology that we'll use in Mach number discussion. So the figure shows the two identical compressor cascade blade. So we have inlet flow velocity vector C1, and also we have outlet flow velocity vector C2. Okay, so the value of inlet Mach number m1 equal to C1 divided by A. So between these two blades, we'll have numbers of point or numbers of position, where this position or this point, individual point will have individual velocity of fluid. Okay, so this individual fluid velocity we call local velocity CL, and individual Mach number for the point we refer as local Mach number, ML equal to CL divided by A. Okay, if we increase the value of C1, which is referred to the inlet flow velocity, the inlet Mach number M1 also increase. So due to the increase of C1 value, the local velocity for each point between the two cascade blades also will increase, and one of the point of fluid will have maximum value in terms of velocity, and that velocity we refer as maximum local velocity CL max. And the Mach number at the specific point or at the specific position we call maximum local Mach number, ML max, which is equal to CL max divided by A. So if we increase further the value of C1, inlet flow velocity, M1 value will increase, and all the velocity local velocity at specific point also will increase further. So when maximum local velocity in term of value equal to the speed of sound, the Mach number at that position will be equal to 1, where maximum local Mach number at that condition, at that point, will be equal to 1. ml max equal to 1 due to the value of maximum local velocity equal to speed of sound. Okay, at this condition, inlet Mach number will be referred to the critical Mach number that represented by MC symbol. Okay, Mach number effect that conduct by Howell 1942. So Howell conduct an experiment about a high-speed cascade testing, where he want to determine the critical and also maximum Mach number. So the figure shows the compressor cascade test section, where Howell for this investigation, Howell will fix the value of incident angle I, and then he changed the value of inlet flow velocity C1. So by changing the value of C1, so Howell will obtain different value of inlet Mach number M1, because if you refer to the Mach number equation, Mach number M1 is a function of C1 and also A. So if we change C1 value, M1 value also will change. Okay, in terms of result, Howell obtained the result of variation of cascade pressure rise coefficient with inlet Mach number. So this result actually specific for blade profile of S over L equal to 0.9, alpha 1 prime equal to 44.5 degree, alpha 2 prime equal to 0.5 degree, alpha 2 star equal to 10.6 degree, and stagger angle equal to 22 degree. And specific for flow condition for Howell investigation in terms of Mach number effect is equal to Reynolds number equal to 30,000. So the graph shows the relationship between pressure rise coefficient Cp equal to delta P divided by half rho C1 square versus inlet Mach number. So the result shown by the blue color curve. So if you can see in the figures, so at the beginning, if we increase the inlet Mach number, we will have the increase of I call the gradual the small increase of pressure rise coefficient. However, at certain point of inlet Mach number, the what I call pressure rise coefficient will drastically reduce when we increase the value of inlet Mach number as shown in the figure. So the highest point or the maximum point of the curve will give you the maximum pressure rise coefficient, where the value will be around 0.339. And at this point, the inlet Mach number value at this point will refer as the critical Mach number, where the value is around 0.36. So we will have this critical Mach number due to, at this condition, the maximum local Mach number ml max in the cascade has reached unity. So this condition we already discussed in previous slide, when we discuss about the what I call the basic information about the Mach number. Okay, so for the region below critical Mach number, the result is valid for both for high speed cascade characteristic and also for low speed cascade characteristic. So after this point, after the critical Mach number condition, we can see that the pressure rise coefficient reduced drastically when we increase the value of inlet Mach number. So when pressure rise decrease or reduce, the performance of the compressor also will reduce. Okay, because pressure rise have direct relationship to the performance of the compressor. Okay, the condition where the pressure rise is equal to 0, we refer as the maximum. In terms of inlet Mach number, we refer as the maximum Mach number, M max. And at this condition, compressor cascade fully choke, where further increase in mass flow is not possible. This is due to all point in the cascade in terms of ML value, local Mach number, already reached equal to 1.0. Okay, and the value of maximum Mach number in for the Howell investigation is around 0.69. Okay, for choke phenomena, choke explanation, we need to refer to the compressor map, where the compressor map really shows you the relationship between pressure ratio and also mass flow rate. Okay, so we will have numbers of constant and curve in the compressor map. So part of the graph we already explained when we discuss about the surging phenomena. So we have two limit line in the graph. First, we have a limit line for surge phenomena, and the second one is limit line for choke phenomena. So if we take only one curve of constant N curve, as shown in the figure, when we increase the value of mass flow rate, the value of pressure ratio will decrease until certain point when no mass flow rate increase is possible and no pressure ratio increase is possible. And this point, where the value in terms of pressure ratio and also mass flow rate is at lowest pressure ratio at highest mass flow rate possible, and this point we refer as choke point. So at this condition, at choke condition, no further increase in mass flow rate is possible due to Mach number reach unity, M equal to 1, in any part of the device. Okay, in terms of Mach number effect, Howell represent different type of data in terms of Mach number effect to the compressor cascade plate. So the result actually refer to the result relative to the critical and also maximum Mach number that obtained in the previous slide. So the first result based on relative critical and also maximum Mach number is the Mach number effect on the decrease of efficiency and also deflection angle in 1942. So the graph shows the variation of efficiency and also deflection with Mach number. So we can see in the graph the result in terms of deflection angle ratio. So the graph is the deflection angle, relative deflection angle based on the critical deflection angle. The second graph is for the efficiency, the relative efficiency, where the ratio actually based on the efficiency at the critical Mach number. Okay, so we have the graph for the y-axis is the value for deflection angle ratio and also efficiency ratio. And for the x-axis we have the Mach number ratio, m minus m critical Mach number divided by maximum Mach number minus critical Mach number. The second graph shows the result in terms of typical cascade critical and also maximum Mach number vary with incident angle. So the result they are obtained by Howell in 1945. So the graph actually refer to the dependence of critical and also maximum Mach number upon incident angle. So the graph shows the maximum number MC or Mach number MC, critical Mach number or maximum Mach number versus incident angle I. So we have two graphs here. So the pink color curve represent the data for critical Mach number, and the blue color curve represent the value for maximum Mach number. So if we have incident angle value, so we can determine critical Mach number and also maximum Mach number by using this graph. Example 3.9. By considering that the value of critical deflection angle and critical efficiency as 25 degree and 0.85 respectively, determine A. the suitable deflection angle and the efficiency if the inlet Mach number is 0.6. B. the suitable deflection angle and the efficiency if the incident angle and the inlet Mach number are negative 22.5 degree and 0.75 respectively. Okay, solution for example 3.9a. Data given: critical deflection angle equal to 25 degree, critical efficiency equal to 0.85, Mach number equal to 0.6. From graph number 1, critical and maximum Mach number can be determined. So from the graph, we obtain that critical Mach number equal to 0.36 and maximum Mach number equal to 0.69. Thus, calculate the Mach number ratio. Mach number ratio equal to 0.73. From graph number 2, by using the Mach number ratio obtained, deflection angle ratio and also efficiency ratio can be determined. Okay, draw vertical line for Mach number ratio, so we can obtain the value for deflection angle ratio. Okay, so deflection angle ratio equal to 0.81, and also you can determine the efficiency ratio, where the efficiency ratio equal to 0.9. Substitute the critical value of deflection angle and efficiency. The deflection angle and efficiency can be determined as below. So the deflection angle will be equal to 20.25 degree and efficiency equal to 0.77. Solution for 3.9, example 3.9b. Okay, data given: critical epsilon equal to 35 degree, critical efficiency equal to 0.85, incident angle negative 2.5 degree, Mach number equal to 0.75. From graph 1, critical and maximum Mach number can be determined by referring to the incident angle given. Okay, by referring to the graph 1 as shown in the slide. Okay, draw the vertical line for incident angle equal to negative 2.5 degree. So from the graph, we can obtain the value for critical Mach number, which is equal to 0.67, maximum Mach number, which is equal to 0.8. Thus, Mach number ratio, calculate the Mach number ratio by using the value of MC and also M max. So we can obtain Mach number ratio equal to 0.62. From graph number 2, by using the Mach number ratio that we obtain, deflection angle ratio and efficiency ratio can be determined by using graph number 2. Okay, from the Mach number ratio, so we can obtain the value of deflection angle ratio, where the value of deflection angle ratio equal to 0.87 and also we can obtain the value of efficiency ratio, where the efficiency ratio equal to 0.95. So substitute the critical values of the efficient angle and efficiency. The deflection angle and efficiency can be determined as below. So deflection angle equal to 21.75 degree, efficiency equal to 0.81. Okay, in order to test your understanding for this part number 6, answer the question below. Question number 1, why do we need to determine the maximum Mach number? Question number 2, what is the criteria for the critical Mach number point? Okay, you have to answer the question by clicking the link provided in my blog. Remember that you need to know the password in order to open the link. The password was given throughout the video related to this topic. The clue is also given in the link. That's all for part number 6, chapter number 3. Assalamualaikum.